This is another part of the battery series. Through experiment I've realised that there's a huge difference between these two drop testers and even this one that I made, which is made out of a 12 volt one with the resistance shortened incredibly, and a meter, and there's a little resistor on that meter to get it to read the right sort of scale. So we need to get to the bottom of this. These two batteries, that's the one you can see there, there's the fix. That's the one that's good, tested. This is the one that had the split in it that has been glued up, and that's been on charge for quite a while. So let's just check a few things. First of all, check the voltage with a trusty multimeter. We want to be on voltage, say put it on 20. I think you can see that. What's that say? 2.11, which is good. 2.1. So they're very similar. So that's a good start. Next thing, specific gravity. Get the hydrometer out. Just twist that around. Now that's a bit low. And that one is just a bit high. Why is that one a bit low? We'll have to investigate that. But let's continue anyway. Again, mind your trousers. What happens is a little drip comes off the end of the hydrometer, drops on your trousers. You never notice it, or on your overalls, or on your shirt. And then a couple of days later you get a little white patch. A day later there's a hole. So there you go. Now, the next thing to do is to clean the terminals up. So, we've already put some bicarb around there. So that's the top of that cleaned up. Then, just for the purposes of experimentation, I've got these big stainless steel washers, and that takes the place of the normal strap, just to take up the space. Bit of Vaseline. So that's nice and clean. This is nice and clean. Problem with 2 volts is you can quite easily, the slightest bit of muck, you will easily lose some current or some voltage because it is such low voltage. Something that 48 volts would go straight through without any bother, 2 volts will be hesitant. So that won't fit. That shows good. That shows good, but about 1.5 volts. This one shows again about the same. 1.5 volts, and on this meter it says at 1.5 volts we'll be drawing about 150 amps. I want to check this, and the only way to really check it is to make up your own resistance and use your own amp meter. Now, I appreciate most people don't have huge great amp meters like this with 5/8 studs sticking out the back, etc. So this amp meter doesn't need a resistance or a shunt to read properly. That is full scale deflection, 200 amps. If you've got small piddly connections, then obviously the meter is not designed to take full current, and you have a resistance across here, so that most of the current goes through the resistance and a little bit goes through the meter. So the resistance and the meter have to be matched. It's in the book. So let's have a go. Now then, just before we start, if you'd been charging these batteries really well and they were gassing, there's no way that you would put a drop tester across it, because the spark might very well set that hydrogen off. And believe me, the top of the battery goes puff into the air with an extremely loud bang, and your battery is duff, there's acid everywhere, your ears are ringing, and we could say it's fair middling dangerous. So if it's gassing like well, just leave it for half an hour or so, flip the top open, let all the hydrogen dissipate. Right, okay, so what I propose to do here, because those are nice and clean now, that top there is not that clean, that bolt, so I think we'll just wire brush that off. That's better. What I propose to do is somewhere, here it is, I've made my own resistance. Now this is the wire out of the old-fashioned storage heaters. They had curly wire and the bricks had got a slot through them, and I think it's about 16 gauge. So let's just check it for those people who want to know. It's actually 1.6 mil. Well, 14 gauge is about 2 mil in diameter, and you can get this stuff quite easily on the web, on these auction houses and all that lot. I don't know. I think there was some 14 gauge 1 meter was about a £5, and I've used, if that's 2 inches, then that's say 4 inches maximum, and I've used 8 pieces. So if you were to use 14 gauge, which is thicker, you'd use less pieces, or these blocks would be further apart. So this end, you can move it this way and that to adjust the amount of current that's flowing through it. So the shorter, the more current, to the point where it starts glowing and burns out. But with this size, that wouldn't happen. And this is nichrome wire, nichrome resistance wire. It's not any old wire. So that's that. So what I propose to do is, I've got these really heavy duty jump leads with welding wire. So let's go off the positive there and into the amp meter on there. See that all right? Yep. And then the other side, come off the amp meter, making sure that that doesn't short on the case, and onto there. And then we can just, we don't want this wire to go onto the battery terminal, we want the block, because it's a resistance between there and there. That shows sparks 60 amps. But that battery is just a little bit low for some unknown reason. 65 amps, 70 amps, 80 amps. It's because I'm pressing there, so the slight bit of resistance, there we go, 80 amps. The slight bit of resistance in between there and that bolt was the difference of 5 or 15 amps. So that was a prime example of how a bit of muck, let's just clean that up. Resist the current. Ah, that was a good 80 amps. Try this one now. See? That bit of muck. There we go. Now, of course, on your car, you're on 12 volts, but the same thing applies. Bits of muck in the connections on the earths or the power leads and stuff, you'll lose current and you'll lose voltage. And so therefore your car won't start. So I always put a separate earth from the battery right to the engine, an extra one, so that on cranking current you've got a direct connection, a big fat cable, no piddly bits and pieces. So now we've sorted that out, what we need to do, let's just test one of these. This is the one that I sort of favour the best at the moment, and we need to get a real good connection on there, and that's drawing 50 amps, and it actually said on the meter it was drawing 100 amps, so I think we're going to ignore these. Let's just try that one there. That's drawing 40 amps, and it says it's drawing more than that. So let's do it the practical way. I'll just remind you about sparks. If you've got hydrogen around, if your batteries have been charging recently, then don't do this until the hydrogen is dissipated and your batteries have stopped gassing. Now what I've done there, I've put that test lead on there, but it's over here. That's the positive. So let's have it on 20 volts. And another test lead. Here we go. Test lead on there. Onto the negative. The resistance. Now that's not very good. Look, it says 0.34. That's awful. Now I thought these batteries were quite good. 0.34. And according to that test, they're duff. Doesn't seem right to me. My experimental data is wrong. How about if we put the meter connections for the voltmeter directly to the battery? Maybe we're getting a false reading somewhere. Okay, so that goes on there. And that goes on there. That's as close as I can get to the terminal. And then the negative, let's go on to, oh, that's not bad. Okay, so we got 2.09 because we're reading batteries now. That's better. 1.96 at 75 amps. And the current staying there and the voltage is staying there. So that's a good battery. It's a very good battery. And it just goes to prove that you've got to understand your data. So let's move that one over to there. And this over to there. 2.06. Okay. Contact 70 amps, 1.93. Well, that one, the battery was a little bit low. I don't know why. We'll have to check that. But it's staying there, and the current and voltage is reasonably stable. I'd say they were all right. So what did we do wrong there? Well, it's obvious when you think about it. There's the meter, and there's the battery. Doesn't really matter which way, positive or negative, doesn't matter for this set of circumstances. So put a jump lead between there and the amp meter. Let's just draw the amp meter. There we go. And then we were coming from the other side of the amp meter through the resistance back to there. And of course we put the voltmeter across there. It's going through the resistance, and that resistance, although we tried to measure the ohms and it was nothing, it was enough to affect the voltmeter. So if we put the voltmeter here, which is what we did the second time, straight across there, then it's not through the resistance. So 1.96. Silly schoolboy mistake, really. But when you're just experimenting and clipping things together, that's what happens sometimes. Right, another thing. These. I had a word with my mate, Al, and he's got one of these, and he says it works perfectly. What he said was, just a throwaway phrase, he said he took the points out. I thought, fair enough. What he said was, they unthread. So, there we go. So what I did was, I wire brushed that up. The threads and that shoulder. I also wire brushed and scraped in that hole. Both of them, you understand, not just one. And then that pops back in there. And now this one does show 2 volts. So again, the smallest amount of muck creates a resistance which affects the meter. This one, where the resistance is welded to those, I cleaned the points. I took these knurled thumb nuts off, undid that, cleaned all that lot up, checked everything, still the same. So it seems like the next thing to do is actually to take the meter off and check it across a 2 volt battery and see what happens. But I suspect this meter is duff in some way or other. But you could use this with a multimeter. So there we go. I've learnt something, and hopefully I've passed it on to you.